In this video, I'm going to discuss 5 different types of redox reactions, and for each one I'm going to give an example, and I'm also going to identify the oxidation number so I can show you where the oxidation and the reduction is taking place. However, before I actually start going through them, I do want to identify or define 2 terms so that we can identify these in these reactions. So something called an oxidizing agent. The oxidizing agent is the molecule containing the atom that gets reduced and then there's a reducing agent, basically the inverse of this. And it's a molecule containing the type of atom that gets oxidized. So what do these mean? Well, the oxidizing agent. The oxidizing agent, again, it's a molecule that contains the species being reduced. So since itself is reducing, that means that it's allowing another species in the chemical reaction to oxidize. Because remember, the oxidizing species loses electrons, and it's giving its electron off so that the reducing species can gain those electrons, right? So if a molecule contains a species being reduced, it's accepting that means it's able to accept electrons, so it's an oxidizing agent because it's able to help facilitate the oxidation of another compound in that reaction. And of course, the same effective principle is true for the reducing agent. The reducing agent contains the species being oxidized, so that means that it contains a species that gives the atom that gives off electrons, so it helps something else reduce. Right? Alright, so our first redox reaction type is a combination reaction. So in a combination reaction, you basically just, as it sounds, taking 2 separate things and putting them together. So, for instance, if we have 2 solid aluminum plus something like this. Alright. So, on the reactant side, solid monatomic aluminum, that is its elemental state. So its oxidation number is 0. And diatomic liquid bromine is actually the natural elemental state of bromine. So its oxidation number is also 0. On the product side, however, product side, aluminum is most of the time going to be +3, because if you think about it, that's the aluminum likes to form a +3 ion, so unless one of the 8 rules I mentioned explicitly forbids it, aluminum will like to form a +3 oxidation number, and none of the rules forbid it here. So aluminum forms +3, and bromine, to basically cancel out the 3 bromines, to cancel out with this +3 and give it a sum of 0, have to be -1. So that means aluminum is going from 0 to +3. Aluminum is going up in its oxidation number. So if it's going up, that means it lost electrons, right? Because if you lose electrons, you're losing negatively charged particles, you get more positive. So that means that aluminum oxidized. So this solid aluminum oxidized, and if it oxidized, that also means that it is the reducing agent. Bromine went down and went from 0 to -1. So bromine reduced because it gained electrons. So Br2 reduced, and that also means it's the oxidizing agent. The next reaction type is a decomposition reaction. So this is actually basically just the opposite of a combination. This is where you take one thing and you break it apart into multiple. Alright, now, on the reactant side, remember, group 1 metals in a molecule will always be +1, so potassium is +1. Oxygen is always going to be -2, except for the 2 exceptions that I mentioned. This is not one of them, so oxygen is going to be -2. Alright, so now you can always set up a little mathematical equation, because a lot of times for things like this, you'll come to one atom that is a little trickier to figure out. So this is a neutral molecule, so the sum of the oxidation numbers has to equal 0. So you can say 0 equals, we have 1 potassium per molecule, and that has an oxidation number of +1, plus we have 1 chlorine, but we don't know its oxidation number, so I'm just going to put X there, plus we have 3 oxygens with an oxidation number of -2. So now equals, let's distribute to the parentheses, 0 equals 1 plus X minus 6, which equals, so 1 minus 6 is -5 plus X. So remember that, this equals 0. So 0 equals -5 plus X, add 5 to both sides, so I'm just doing some basic algebra here, X equals 5. That is your oxidation number for chlorine, +5. Alright? So you can always try to, if you get down to one last one, you can always set up a mathematical equation like that to help you figure it out. On the product side, again, potassium is still going to be +1 because it's in a molecule. Let me try my other black Sharpie. Alright, so chlorine, to make this sum 0, has to be -1. And this is the elemental state for oxygen, so that's going to be 0. So potassium did not change. Chlorine, though, chlorine went from +5 to -1. So chlorine here is what is the species that reduced, while oxygen went from -2 to 0. That went up, so that oxidized. As it turns out, since we're only starting with one molecule to begin with, the KClO3, it happens to be both the oxidizing agent and the reducing agent simultaneously.